In this module, what we are going to do is we are going to discuss the basics of number system. So I'm going to teach you the different types of numbers. Then we will move on to LCM, HCF concepts. Okay. Then we will solve a few problems, one or two examples. So I will take up one classical example from time and work, the application of LCM in time and work. Then I'll take one example from speed distance time, the application of LCM HCF concept in speed distance time. Okay. Then the standard LCM HCF question also, one or two I will solve. The agenda is basically not to solve questions. We'll try to understand what you mean by LCM and HCF and how will you solve questions. Then question solutions as a separate session, as we have done in case of reminders, we will do it later. Okay. Then after that, in the second session, in the second video, I will be discussing complete details about factors. Factors, where in that chapter I will cover questions like number of factors, okay, sum of factors, product of factors, number of even factors, number of odd factors. In fact, all the possible questions from factors I will cover in the second video. Then after that, I will cover everything which is related to factorials. Okay, so hope you will be knowing about factorials, but we will cover complete about factorials in the third video session. Okay, so factorial is actually the product of consecutive numbers starting from 1. So when you cover product of numbers starting from 1, that is factorials, obviously we will have to cover sum of consecutive numbers starting from 1, that is sigma n. So you will get questions based on factorials also, you will get questions based on sigma n. So factorial is nothing but product of consecutive numbers from 1. Sigma n is sum of consecutive numbers from 1. Okay, we will discuss enough examples when it comes to that particular video sessions. Okay, so these are the 4 videos which are involved in this module, and after that I'll take one session. Within that I'll cover maximum questions. Okay, so what all things we have discussed, I'll take 1 or 2 sessions to discuss about all the questions. With that, our understanding will be complete about these topics: LCM, HCF, factors, factorials, and sigma n. Okay, so what do you mean by sigma n? Sigma n is sum of consecutive natural numbers. You'll get questions like this: a person is adding the page numbers of a book. That means he's adding the page numbers, means he's actually finding sigma n, sum of consecutive natural numbers, right? And he's missing a page and he got some number, so what page number he missed out? Or he's adding a page extra and he got some number, so they will be giving you that number and they will ask you what page number he missed out. So this kind of questions will solve by using sigma n concept. Okay, so we'll come to that. So let's start off with the basics. Now let me give you a brief introduction about numbers and number system. So what do you mean by natural numbers? Natural numbers are 1, 2, 3, 4, etc. Set of 1, 2, 3, 4, 5, 6 up to infinity, the positive numbers, right? Then when I say whole numbers, what are whole numbers? You add 0 to natural numbers, right? So 0, 1, 2, 3, etc. This is what whole numbers. Okay, so if you take some numbers from this 2 and 3 or 3 and 4, etc. Okay, any 2 number you take, you add. Let's suppose you took 2 and 3, you add, you get 5. That 5 you will get in this series itself. Okay, if you take 3 and 4, you get 7. That 7 also you can represent in the same set, that is in natural number or whole number, right? But if you subtract, you take 3 and 4, you subtract 3 minus 4, you get minus 1. The problem is, where will I represent minus 1? So to represent this operation, the answer is minus 1. I need another set of numbers where you get minus numbers also, right? And that's where we introduced integers. Okay, so integers include negative numbers also. So it's like up to negative infinity it will go, minus 3, minus 2, minus 1. It will include 0 also, then 1, 2, 3, etc. So if you observe here, all natural numbers are whole numbers or whole numbers are integers, and the vice versa is not true. You take 4, 4 is coming in whole numbers as well as in integers. But if you take minus 2 will not come in whole number. If you take 0, 0 will not come in natural number. So the vice versa is not true. Okay, now again, next is actually the next is rational numbers. So what do you mean by rational numbers? Again, you take 2 numbers from this. Let's take 2 and 3. Okay, 2 into 3 you get 6. 6 you can represent in the integers, or you can represent in the whole number, or if you want, you can represent in natural number. If you take minus 1 and 6, you get, when you multiply, you get minus 6. That also you can represent in integer. But when you divide, there is a problem, right? So 2 by 3, if you need to divide, where will you represent? Okay, so we need rational numbers to represent this operation. So rational numbers are basically those numbers which are in the form p by q, where q is not equal to 0, and p and q are integers. So p and q can be any number from this integer, and q should not be 0. That is a condition. All these numbers are rational numbers. So we have rational numbers. What are those? Like 2 by 3, 3 by 4, etc. These are rational numbers. Now you take any two numbers like 1 and 2. Okay, you take any two numbers 1, 2. What is midpoint of 1 and 2? It is actually 1.5, right? What is 1.5? It's actually 3 by 2. So 3 by 2 is a rational number. Why? It is of the form p by q, where p and q are integers and q is not equal to 0. So you got one rational number between two numbers, right? Now if you take midpoint of 1 and 1.5, okay, you get another rational number. If you take midpoint of this two, you get another rational number, and you can keep on doing this. So basically what I need to tell you is there are infinite number of rational numbers between any two integers. You take any two integers, there are infinite number of rational numbers. Now will you get it? You just take the mean, or you just take the midpoints. Now how will you take the midpoints? Basically you need to take the average. That's what I mean by mean. Okay, so between 2 and 3, if you see, you take the average. So that is 2.5. That is actually 5 by 2 is the midpoint. Okay, so between 2 and 3, first midpoint is 2.5, 5 by 2. Then between 2 and 2.5, you can see the midpoint. Between 3 and 2.5, you can see the midpoint. And you can keep on finding the midpoint. So in each case, you are actually getting a rational number. Now, the question is, can an integer be a rational number? Let's take 3. 3 is an integer. Can it be a rational number? Yes, it is a rational number, because I can write 3 as 3 by 1. This is of the form p by q, where p and q are integers and q is not equal to 0. So all the integers are in fact rational numbers, and between any two integers there are infinite number of rational numbers further. I hope this is clear for all of you. Now if you see, what all things we have discussed is actually natural numbers, whole numbers, integers and rational numbers. Now you can conclude like this: all natural numbers are whole numbers. So you can write like this: this is natural number, so all natural numbers are whole numbers. Now all whole numbers are integers, all integers are rational numbers, and the vice versa is not true. You take an example, minus 2 by 3 or 2 by 3 is a rational number but not an integer. Minus 3 is an integer but not a whole number. 0 is a whole number but not a natural number. I hope this is clear for all of you. Then what do you mean by irrational numbers? There are certain numbers like root 2, root 3, pi, etc. These are irrational numbers. Now these numbers, if you expand, root 2, root 3, pi, etc., these are non-terminating and non-recurring numbers. Okay, so pi you are writing as 22 by 7, but if you do this operation, you will not get a terminating or recurring number. So it keeps on going like that, and to make the calculation easier, you take it as 22 by 7 or 3.14. So these are irrational numbers. So basically those numbers which are not rational, irrational number. And this rational number plus irrational number together we call as real numbers. So real numbers means rational number plus irrational number. So what all things we have discussed is basically, it's like this: all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers, the numbers other than rational numbers are irrationals. All these together we call as real numbers. So real number comprise of rational and irrational. Now next is, what do you mean by prime numbers? So prime numbers. Prime numbers are those numbers which is having exactly two factors. Okay, and what are the factors? 1 and that number itself. So you take a number 2. If I ask you what are the factors, 1 and 2, 7, 1 and 7, 13, 1 and 13, and 1 and that number itself will be a factor of all the numbers. So apart from this 2, there are no other factors. So we call these numbers are prime numbers. So prime numbers have exactly two factors, and the factors are 1 and that number itself. Then what do you mean by composite numbers? Numbers other than prime numbers are composite number. Basically numbers which is having more than two factors are composite number. You take 10, 10 is a composite number. Why? 2 is a factor, 5 is a factor, 1 is a factor, 10 is a factor. More than 2 factors. So we call it as composite numbers. And what about 1? 1 is neither a prime number nor a composite number. And the speciality of 2 is basically 2 is the only even prime number. Any other even number you take, 2 will be a factor. So no other even number cannot be a prime number. So 2 is the only even prime number, and that's the speciality of 2. So I hope you understood prime number and composite number. Then what do you mean by coprime numbers? Coprime numbers are basically relatively prime numbers. It's like this. You take any two numbers. Let's take 2 and 3. If you see the highest common factor of this, it's actually 1. There are no other common factor except 1. So these numbers are called as coprime numbers. No other common factors except 1. No other common factors except 1. You take 2 and 4, there is a common factor 2. So these are not coprime numbers. But 2 and 3 are coprime numbers. What about 3 and 4? 3 and 4 are coprime numbers. There are no other common factors except 1. So coprime numbers means relatively prime number. So between them, there are no other common factor except 1. So that's what coprime number. Now, if you see two consecutive natural numbers, let's take 2 3 or 3 4 or 5 6 or 17 18. Two consecutive natural numbers are always coprime numbers. Similarly, two prime numbers if you take, okay, obviously it will be coprime number. 3 7 coprime numbers, 17 23 coprime numbers. So two consecutive natural numbers are coprime numbers. Two consecutive prime numbers will be coprime numbers. Two consecutive odd numbers will also be coprime numbers. You take 3 and 5 or 31 33 or 37 39 will be coprime numbers. So two consecutive natural numbers, two consecutive odd numbers, and any two prime numbers, all these are coprime numbers. We'll come to know about coprime numbers in detail when we discuss about remainders. In fact, we have done this discussion when we discussed about Euler's number and when we discussed about Fermat theorem for finding the remainders faster. So those who have seen those videos, you will be able to relate it to coprime numbers faster. And I have given you a method also to find the coprime numbers, right? N into 1 minus 1 by A into 1 minus 1 by B. And this is not required now. We have discussed this in detail when we discussed about Euler's number. Okay, so I hope you understood the basic concepts related to numbers. Now we are moving on to the next topic, prime factorization. See, we are actually discussing about LCM and HCF. So once we complete the basics, I am moving on to LCM and HCF. So this is the last topic which I need to discuss, prime factorization. With that, I will complete the basics and we'll move on to LCM HCF. Okay, so what do you mean by prime factorization? It's actually, you will be having a composite number. You need to write that composite number in terms of prime numbers. So how will you write? Let's take 6. How will you write it as prime numbers? You write it as 2 into 3. So 8, how will you write? 2 into 2 into 2. 9, how will you write? 3 into 3. 30, how will you write? 2 into 3 into 5. 60, how will you write? 2 into 2 into 3 into 5. So this is how you will do the prime factorization. Basically, the given composite number you will be writing in terms of prime numbers, and that's what you mean by prime factorization. Now let's see some examples. So if I give you 60, how will you prime factorize? 60, you will write it as 15 into 4, right? And 4 is 2 square, so 2 square into 15 is 3 into 5. That's how you'll prime factorize. Or you can do the division, 60 divided by 2. You start with the first prime number, then you get 30, then further divide by 2 you get 15. Now you can't divide with 2. See the next prime number. So that is 3 and 5. You can prime factorize like this also, but it will take time. Okay. But when you are writing an exam, you should go with this method. Just think like this, 15 into 4. 15 is 3 into 5. 4 is 2 into 2. So your answer is ready. What about 72? So how will you think? You need to take it in this way. 8 into 9 is 72. And 8 is 2 cube. 9 is 3 square. That's it. So if I give you one more number, what about 96? 96 is actually 32 into 3. So 32 means 2 raised to 5 into 3. So that's how you'll prime factorize those three numbers. Now let's move on to the concept of LCM. How will you find LCM? Okay. So if we need to find LCM, okay, let's find LCM of, so we need to find LCM of 60, 72, 96. Okay, I hope you might be knowing about the division method, but that's not worth using while exam. So better approach is basically prime factorization. Okay, so if you can factorize the numbers faster like this, and in most cases you can factorize easily. Okay, so how will you do it? You have how to find LCM is basically, if you see how many factors are there, 2 is there, 3 is there, 5 is there, right? So here also 2 and 3, here also 2 and 3. So your LCM will contain all these 3 factors, 2 and 3 and 5. All those 3 prime factors. Now what the power you will write? You see where you get the highest power for 2. You get highest power here. So take that highest power and write that power. Where you get the highest power of 3? Here. So write the highest powers. And where you get the 5? That is only 1. So 1 itself. And this is what your LCM. So what you will do to find LCM? Prime factorize the number. See how many prime factors are involved. Write all the prime factors and take the highest power of each prime factor. Now what is this concept LCM? See, if I ask you to find LCM of x, y, z, what is it? I am actually looking for a number which is divisible by x, y, z. So I am looking for a number which is divisible by the given 3 numbers. So LCM of 60, 72 and 96 means I am looking for a number which is divisible by 60, 72 and 96. And LCM is the only such number? No. There are many numbers, but why LCM? LCM is the lowest common multiple of all the 3. So this is the lowest number. I am looking for the lowest number. Otherwise, there are many other numbers. If you find LCM, add LCM, that will also be divisible by all the 3. But I need the lowest number. Now, you can check with this itself whether you can divide with 60, 72 and 96. Okay. So I told you this is your LCM. You can check whether you can divide by 60. So 60 means 2 raised to 2 into 3 into 5. So can I divide? I can divide because one 5 is there, right? Then one 3 is there, I can divide. Then 2 2's are there, so I can divide it, right? Similarly 72 is what? 2 cube into 3 square. So I can divide 3 square here, 2 cube also I can divide. I get a quotient. Similarly 96 is 3 into 2 raised to 5. 2 raised to 5 is here, I'll get a 3 here, I can divide. So this is what my LCM. LCM of 60, 70 to 96. Why it is called as LCM? That is the lowest common multiple of 60, 72 and 96. What does that mean? You can divide that number by 60, 72 and 96. No remainders. So LCM of x, y, z means I am looking for a number which is divisible by x, no remainder, y, no remainder, z, no remainder. That means divisible by x, y, z completely. That's what LCM. So LCM will obviously greater than the given 3 numbers because you need to divide the LCM by the 3 numbers. So LCM will be greater, and that's what you need to remember. If you have any confusion between LCM and HCF, LCM will always be greater than the number because that number you are going to divide with the 3 numbers or 4 numbers or 2 numbers which is given. Now, what is HCF? HCF is the highest common factor. Okay, so basically you need to find the common factors here. 2 is there in all, 3 is there in all. So your HCF will contain 2 and 3. But how much 2 is there in all? Here you have 2 square, 2 cube, 2 raised to 5. 2 square is common in all. So I will take 2 square. So 3 only and 3 square and 3. So how many 3's I will take? I will take only 1. 1 3 is common in all. So this is what your HCF. So in case of LCM, you will write all the prime factors with the highest power. In case of HCF, you will write only the common factors with the lowest power. So here lowest power is 2, lowest power of 3 is 1. So that's what your answer. And your answer is 12. Then what is HCF? You need to find the HCF of x, y, z. Okay. So HCF means HCF will be a number, right? With this number, you can divide x, you can divide y, you can divide z completely without any remainder. So LCM means LCM is divisible by all the 3. HCF means by using HCF, you can divide all the 3. And is it the only number with which you can divide all the 3? No. This is the highest number. See, if I can divide these numbers with 12, I can also divide these numbers with the factors of 12. That means 6, 4, 2, 1, etc. For that matter, all the numbers are divisible by 1. But why 12? 12 is the highest number. More than this, I can't get any number with which you can divide all the 3 numbers. Less than that, I can get numbers. 6 is possible, 4 is possible, 3 is possible, 1 is possible, 2 is possible because all these are factors of 12. But if you take any number more than 12 like 24 or 48, it is not possible. I hope the concept of LCM and HCF is clear for all of you. Now there is another easy method of finding HCF. Okay, see, if you need to find the HCF of this numbers 60, 72, 96, you take the difference between these numbers. This is 12, this is 24, this is 36. In 90% of the time, in 90% of the cases, the smallest number which you got will be your HCF. And here also there is no exception. Here also you got 12 was your HCF. So if numbers are given, you just take the smallest number. 90% of the cases you get HCF. Now what are the exceptions? That also I tell you, because just like this you cannot take HCF, right? You need to know the reason. Understanding the reason may take some amount of time and it is slightly difficult, but once you understood it is easily. You just need to take the smallest difference only, you get the HCF. Now why is it working is what we need to see, right? See, it's like this. The idea is your HCF will be there in the factors of the differences, right? So what are the differences? 12, 24, 36. So your HCF will be there in this 3 and the differences. Okay, so your HCF will be there in the factors of these 3 differences. So if you see, one of the factor of 36 is 36 itself. One of the factor of 24 is 24 itself. But 36 and 24 is not the factor of 12. But my HCF is my HCF will be there in the factors of all the differences, right? That means it should be there in 12 also. So if 36 is my HCF, it is not there in 12. So 36 cannot be my HCF. 24 cannot be my HCF. So basically I don't want to check the factors of these big numbers. I just need to check the factors of 12 only. So my HCF will be there in the factors of 12 here. In general, my HCF will be there in the factors of the smallest difference. I am not telling you your HCF is the smallest difference itself. Your HCF will be there in the factors of the smallest difference. So what are the factors of 12? 1, 12, 2, 6, 3, 4. So one among this will be your HCF. And most probably the highest common factor will be the highest factor itself. But you need to check it. So here you take 12 and check whether I can divide 60 with 12. Yes. 72 with 12. Yes. 96 with 12. Yes. Then what is your HCF? 12. If you cannot divide any of the number with 12, what you'll do? You take the next highest number, 6. Check 60, check 72 and check 96. If you can divide, that's your HCF. If that is not possible, you try with 4. If that can't divide all the 3, try with 3. If that can't divide, try with 2. Or you try with 1. So finally 1 will be the answer. So if I ask you directly, what is the HCF of 127, 128? What is your answer? Your answer is just the difference, 1. You don't want to do all these things that you have done earlier, trying to find the common factors and all. Just find the difference. So simply if I ask you 1379, 1389, what is HCF? You take the difference. What is the difference? Difference is 10. What is the idea? The idea is your HCF will be there in the factors of the difference. So here 10 is the difference. Factors means 1, 10, 2, 5. Any other factor? No. So what you need to do? You need to check whether I can divide with 10. So by looking into this itself, you understood it. 10 is not possible. 5 is not possible. 2 is not possible because 2 are odd numbers. What is your HCF? 1. So this is very easy method. If you can take the difference, or if I give you 117, 119, 236, just like this random numbers, what you will generally do, you try to divide, you try to find the common factor, right? 2, 3, 5, 7, you keep on checking it. That's not worth doing in exam. So just take the smallest difference. 2 is the difference. So now I understood it's either 1 or 2. 1 or 2 is the HCF. Can it be 2? No, because this is odd number. So what is HCF? HCF is 1. So what if you have 118, 124, 337? What is your answer? You take the smallest difference here, 6. So factors of 6, that means 1, 6, 2, 3. Any of this is your HCF. 6 cannot be the HCF because it is odd number. And then you need to check for 3. 3 plus 3, 6. 6 plus 7, 13. So 3 is also not possible because sum of numbers is not getting a multiple of 3. You know the divisibility of 3, right? Then it can't be 2. So what is your answer? 1. Now, what if this is 338 or this is 336? What is answer? You take the small difference, that is 6. Now check whether I can divide with 6. So this is 10. Sum when you take 8 plus 2, 10. So not possible with 6. 3, not possible because this is not possible to divide with 3. What about 2? Yes, you can divide this with 2, this with 2, this with 2. So 2 is the HCF. Very simple. Otherwise, what you will do? First step you will do this. You divide with 2, you get 54. you get 62, you get 163. This much everybody will do. Then you keep on thinking, what is the next number? And you will end up thinking. You will waste at least 50 seconds for that. Okay, so HCF you can find faster just by taking the smallest difference. Here you got the answer faster. Now one more thing I tell you, in case if you need to check whether a number is prime or not, you may get questions like how to check whether the given number is prime or not. Just like this, if you need to check 239, whether this is prime or not, how will you check? What you need to do is, you take the approximate root of 239. Okay, you know 225 is the square of 15, 256 is the square of 16. So it is actually between 15 and 16. Okay, so this is actually 15. So root 239 lie between 15 and 16. That's what you know, right? So, and I don't want to write all these things. I just need to know this is 15. So what I need to do is take the prime numbers till 15. What are they? 2, 3, 5, 7, 11, 13. These are the prime numbers till 15. So what is 15? 15 is the, when you take the root of it, you get 15. Okay, between 15 and 16, so I take 15. Take prime numbers up to 15. And you start dividing 239 with these prime numbers. So 239 by 2, can you divide? No. Similarly, 239 by 3, can you divide? No. 239 by 5, you can't divide. 239 by 7, also you can't divide. 239 by 11, you can't divide. 239 by 13, you can't divide. Now, if you cannot divide with all these prime numbers less than 15, it's a prime number. If you can divide with any of the number, that means that number is a factor, so it cannot be a prime number. I hope this is clear. So if you need to check a number is prime or not, take approximate root of it and see the prime numbers till that number and start dividing. Okay, if you can divide with any of the number, that's not a prime number because it's a factor. That's why you can divide. If you cannot divide with any of the prime numbers, the given number is a prime number. So that is 239 is a prime number. So what we did is, you find the root of 239. So if you need to generalize, you need to check whether x is a prime number or not. What you need to do? Find root x. So let's suppose you got y. Then what you need to do? You need to know the prime numbers up to y. Here, prime numbers up to 15. Then you need to divide x with all the prime numbers. If you can divide with any of the number, it's not a prime number. If you can divide with any of the prime number, it's not a prime number because it's a factor. Otherwise, it's a prime number.